1, 0, and liftoff.
One of the most challenging aspects of this mission happens before we even land, and it's picking the right landing site for the mission. We want to study the habitability of Mars. We want to really figure out if it was ever capable of supporting life. And the way we do that is to really follow the evidence of water on Mars. One of the most interesting things about Mars is that it's changed over time. What we see on Mars today is very different from what occurred in the distant past. And water is the real interesting thing that we're looking for, the history of water, how it's changed over time. One of the biggest challenges to studying habitability on Mars, which is the goal of the Curiosity rover mission, is to try to follow that signature of water. Where was the water? How long was it there? And where do we go to look for evidence of it? If we were somewhere like this, where there's a pretty obvious geologic record of water flowing, carrying material down, that would be a home run. But the real challenge is finding that one spot on Mars to send this great rover mission to. We have 4 wonderful landing sites, all very different in character. And the real challenge for us as scientists is to come to a consensus on which one of those sites offers the best chance of fulfilling the goals of the mission. There's a place on Mars called Mars Vallis, which has the brightest mineral signature of clay minerals on Mars. And these clay minerals are known to form in the presence of water and neutral pH water, not acidic, not too basic, just the kind of water that would be friendly to life. Then you have terrestrial geologists who say that the rock record should be the thing that we follow, the landforms that look like they were carved by rivers or floods. So you have sites like Holden crater, which is a big impact crater many miles across with a river coming into it, perhaps forming a lake multiple times and flooding the crater, leaving a geologic record that we can study with Curiosity. Just upstream a little bit from Holden crater, there's a place called EBERSWALDE crater. That same river system in Eberswalde has left evidence of a delta. Just like the Mississippi River Delta, these things form when muddy, silty water deposits its silt, its mud, into a formation, into a standing body of water, like a lake. And so you have people that study deltas on Earth who think that's the place Curiosity should go. The final site is the best place on Mars if you want to just study layered materials. So why do we like layered materials? Because just like this outcrop behind me, they give a record of time, of how things change over time. By studying different layers, you can rebuild the geologic history of Mars. So there's a place called GALE crater, which has a 3-mile stack of layered rocks. Now we don't exactly know how those layers formed, and the mineralogical evidence isn't as strong as other sites, but people who just think layers are the thing to study really love GALE. So you have these 4 different sites and these 4 different groups and very passionate arguments back and forth to try to really narrow in on what is the one site to send the Curiosity rover.